Hello time travelers! Here's a video that many people requested. How to train a face in a LoRa for SDXL to use an automatic 1111. This is my look of disapproval. The first thing you need to do is update your Kohya. So have a command line window open to your Kohya folder already, and if you don't know how to do that, you press Windows button R on your keyboard so you have this window and you type CMD. And then let's say this is your Kohya folder right here. You type CD space /D space double quote and just copy paste this over. That's it. Once you're in here, all you got to do is type GIT space PULL and then press enter. And that's going to update your Kohya. But its dependencies are not updated yet. Because you don't want to run it just yet. Just type setup.bat and press enter. And it runs the setup.bat thingy, what's it, that the Kohya developers so kindly made for us, and you choose option 1. This new version says the version 1's not going to be around anymore after a while. So hit 2. And by the way, if you haven't seen my video on how to train LoRa's, please just pause this video or come back to it, but click this card right here, bloop, and go watch that. For example, if you haven't installed Kohya yet, you need to follow those instructions. I'm not going to go over every minute detail in this video. Like, for example, how to install the support for CUDNN. See what I mean? Installing modules, installing package, installing blah blah blah, installing blah 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 blah, copying bits and bytes. All right, when you get to this part, you don't want to change the option. Just leave it on this machine and press enter. And then leave it on no distributed training and press enter. And then, do you want to run your training on CPU only? No, that would be bad. It would be super stupid slow. Type no and press enter. Do you want to optimize your script with Dynamo? It can't talk. No. Do you want to do the deep speed? No. What? What GPU should be used on this training machine? Comma separated list. Oh. Actually, this machine has 2 GPUs installed for testing, and even though I try to tell it GPUs by ID here, it doesn't work, so I have to choose all. There's another command line later on that you use to tell it which GPU to use. And since the GPU in here that I'm going to use is RTX 3080 Ti, which supports BF16, I'm going to choose that by using the arrows and hit enter. If you have like a 10 series, choose that. If you have a 40 series or a 30 series, choose BF. If you did already download your CUDNN files, hit option 2. I've already done that. Again, I provide a link for all that good stuff in the previous video. And when it's finished, just choose option 6 and press enter, because we don't want to run it just yet. And now we're going to be taking care of the regularization images. This is the GitHub for the regularization images that I use, and they work really good. And the previous video called him the Saint Goat, or whatever I said. I'm still using his stuff. Again, you got to watch that video and be familiar with all that. But we do need to upgrade the images to 1024 by 1024. What I did was I made a new folder. I'll make an example. So hit Control-Shift-N. In my case, I'll make an example folder to show you guys. But I'm going to call it SDXL-demo. Open that up. Control-Shift-N and make a new folder. Woman-training-folder. Open that up, Control-Shift-N and make another folder and put one_woman. And then just leave that folder alone for now. Now you're going to download an upscaler that I tested that seemed to work well with this. And I'll have the link in the URL down below. And snap, it's gone. What? At least I remember the name of it. Let's Google it, see if we can find it. It's called Huge Peeps V1.pth. Oh. I found it on somebody's OneDrive. You guys better grab this fast. It's a great upscaler. I'll have this linked in the description, obviously. You download this. I'll show you where to put it. You go to your Stable Diffusion Web UI folder, and then Models, and then Ergran. And see, I already have it right there. There's a few others. If you're interested in testing these other ones, it's in my video about getting ready to train embeddings. And you can get that card right here. In that video, the timestamp you want to go to is at 6 minutes 34 seconds. Just trying to save you guys time. So in Stable Diffusion, you want to go to your Extras tab and then batch from directory. The input directory, you want to go to your regularization data images folder and find your SD 2.1 folder and then woman. And then we're just going to hit Alt D to put the cursor up there. and then hit Control C to copy it and put that here in the input, and then go back to where you get your SDXL demo, woman training, one woman, and Alt D, Control C, and then Control V that over there. Hey, it's future me. Sorry, I was a bit loopy, fruity loopy, because I was tired. Maybe you caught that earlier in the video because I couldn't talk right. But what I did was put in the folder paths for the input directory and the output directory. You're not going to use scale by. Instead, we're going to use scale to and change this to 1024 by 1024. Don't worry about this. It's not going to crop because we're going square image. That's 1:1 aspect ratio to square image. It's 1:1 aspect ratio again. I'm going to put huge peeps in here. Leave upscaler visibility and upscaler 2 alone. And GFPG, whatever that is, visibility alone. Put 0.765 in that one. And then 1 in that one. I'm not 100% sure on what these do, and these are like me sliding the slider back and forth until I got good results. That's back when I was just learning how to use the upscaler, not necessarily training, and those seem to work. And then click generate. I forgot to say that I clicked generate when I was recording. Past me was a sleepyhead, and maybe this will crash for you. If it crashes, I recommend restarting the computer and trying again with nothing else running. Check this out. I've got the 2 GPUs on this machine, the 3080 Ti and the 1660 Super. And by default, when you launch Stable Diffusion or Kohya, it uses GPU 0, so it's using my better GPU with more VRAM. But I'm gonna run my GPU stats batch file so I can keep an eye on the VRAM. Oh look, it's all bugging out. I need to upgrade it to support multiple GPUs. If you only have one GPU, this is a good tool. You also got Hardware Info 64, or you've got the Task Manager, but that's not as accurate. If you install Hardware Info 64, run it with the Sensors Only checkbox. And I'm looking at my 1660 Super here, and it's not using any of that VRAM, see? Because that's like a really tiny number, that's megabytes. Let's look at the 3080 Ti, and I've allocated 10 gigabytes out of the 12, but I'm only using like 9.8, okay. And look, it started generating images over here. I'll show you how good they come out with that upscaler. So we just looked at those first 3. Go back to the 2.1 so I can show you how similar they are. These are grainy, but the ones I upscaled, it got rid of all the graininess. In this case, I wish I could preserve the graininess, and maybe that's something you guys can try a different upscaler if you want and tell me if you got it. The reason why is because I want to respect whatever mechanism makes the regularization's images work. And whatever 2B Kubabur, or however you say his name, he made them work for my other LoRa trainings. But anyways, I digress. The next step is to wait ages. Actually, you can open the destination folder and watch this number on the bottom left. Right now, it says 24 items. And the magical number that we're waiting for is 5,000. You may need to press F5 on your keyboard, like, you know, click in an open space without clicking on any of the images, like that. And then hit F5. But actually, after an hour and a half of the first time of me making these, I came back and it had only done 825 images. So I did the math. This is how I do math like this, by equalizing fractions. 1.5 hours at 825 images made, and I need 5,000. So to figure out how much total time there was, I figured out 9.09 hours. It was 1.5 times 5,000. Enter, divided by 825. It's an equalizing fractions trick I learned, where you look at 2 fractions where you got, 4 variables and there's one you don't know. You multiply by the diagonal ones that do exist and divide by whichever one is left. So, as my notes say, so screw that, go to bed and sleep in for the freaking weekend while your computer makes your regularization whatsits. In my case, I'm stopping this. Stop! Stop! I already have some. I already made these. I'm pressing Control C. Stop now. Thank you. Terminate batch job. Thank you very much. So a little bit of information about memory use. So I already showed you a couple of ways to keep an eye on the memory use. One was Hardware 64. The other one was that script you can download from my GitHub repo. I did initial testing on an RTX 3090 with all the same settings as my previous tutorial video on how to train LoRa's. Except I changed the max resolution to 1024 by 1024. Caching latents took 10 minutes instead of 4, and that was the same on both the RTX 3090 and the 3080 Ti. Also in my testing, I used the 768 by 768 regularization data from the same place we were just at. I requested that he made 1024 by 1024 stuff, but he hasn't responded. Maybe y'all can go on his GitHub and upvote me, however that works. I don't know how that works. I will talk more about VRAM use later in the video. Okay, now we're going to talk about prepping your data source images, because they got to be 1024 by 1024. And basically all the same rules that I told you in the previous video apply. But I'm going to show you a couple tricks. First of all, I've been using Brave more for this. Go to images.google.com. Maybe Chrome will do this, Firefox won't. What I'm about to show you. So let's say I'm looking up pictures for Rebecca Ferguson. And you've got Instagram, for example. And you want this picture. No, I don't want that picture. That's way too grainy even to upscale it. So let's say it's this one. It says 1440 by 1800. So what Sleepy Past Me is trying to tell you is to find images that have both a width and a height that's greater than 1024 pixels. But I do get around to it in a minute. And you download it and it's not that big. You right click it and then hit open it in a new tab. Then in here in Instagram, you right click it and hit inspect. Wait for this to load, right click it and hit inspect again to make sure that this div is correct to what this is. I mean, it matches. And then you find the one that turns green when you hover your mouse over it and expand that div and slide this over. And sometimes you have different size images, but it's typically, I think it's the bottom one you want. Hover your mouse over that and then go down. It keeps trying to get away from you. It's annoying, but go down to this one and then it opens the image in a new tab and download this. That's the bigger picture. The second trick, and someone told me in the comments, I'm sorry, I can't remember your name right now, about this, and I had to figure out what he meant because he didn't tell me how to do it. But you go to Tools, Size, Large. So it only shows you the large pictures. And then you look at the corner of the picture right here and make sure at least most of your images are 1024 by 1024 so that you have to upscale much less of them and make less work for yourself. And a third thing I figured out later, here's an example of a dark picture. If you're in Irfan view, you hit Shift and U, and it'll shift the colors. I don't like what it did to that one, but it's image, auto adjust colors. So you've got an image that's super dark. It'll brighten it up. This particular one, I would not brighten it up because it's just really good cinematic color grading. Keep in mind, if you've got a massive resolution like that, it's gonna take a little while for it to do the work on the picture. And when you're using upscalers, I don't want to zoom in on the bajungas. I'm trying to show the face. Make sure it doesn't look all zigzaggy around the eyes and in weird lines and stuff. If that's happening, then you need to go back in here and try a different upscaler and try, instead of doing 0.765 and a 1, make all 4 of these a 0.25. And what I've done often is, for example, I'll use like JPEG Destroyer. You can Google that or check the previous video how to find that, followed by Ultra Sharp. Well, just a couple ideas. Before I move on to the next part, I do need to do like a PSA to y'all. If your GPU is not NVIDIA, or you don't have one with 12 gigabytes or more of VRAM yet, look at these prices at eBay. I mean, this could be your AI stuff GPU for the next couple years for 200 bucks. What Past Me is talking about is the RTX 3060 12 gigabyte model. But if you go to buy one, be careful that you don't get the 8 gigabyte one because it's the same price. But I did testing on the following GPUs: RTX 3090 with 24 gigs of VRAM, RTX 3080 Ti, which has 12 gigabytes of VRAM, and the RTX 3070, which has 8 gigabytes of VRAM. The 3070 had memory errors or insane ETA times, like a few hundred freaking hours, unless I changed something in training that's dramatically reduced the quality. I'm planning on doing an extended video about explaining why this is good for you. If you guys are interested in that, tell me in the comments to tell you why a 12 gigabyte GPU is good. Right now, I'm running all this stuff on a machine that's got 2 GPUs to show you that you can isolate Kohya and automatic1111 and tell them which GPU to use. See? 1660 Super and a 3080 Ti. Now we are going to load Kohya and set the source model for SDXL LoRa training. So make sure you don't have Stable Diffusion running and go in command line to your Kohya folder and type goya-user.bat. Press enter. Lol, I said Goya user.bat, but you know what I mean. And if you already have like some 768 or some other config file, I recommend you load that first. Go to the LoRa tab and then training, configuration file, and then open. And there's my 768 one. Now the next thing you want to do is change your model quick pick off of whatever you had before to the SDXL Base. It's here on Hugging Face. I'll have it linked in the descriptables below, but I did talk more in depth about each one of these base models in my previous video about getting the dev version of automatic11 working so that SDXL, it runs much faster, and the card is right here if you want to watch that later. The one you want for training is SDXL Base 1.0. You're going to want to download both of these. Watch that other video, but whatever. I already have it downloaded, so what you do is under Model Quick Pick, you change it to Custom and hit this Browse File icon, and we're going to navigate to it. And just like I said, I did it in the SDXL Dev video. I'm going to where I keep it, which is Models, Stable Diffusion, SDXL, and then SDXL Base 1.0. Now, again, this checkbox is if you're using a SD 2.0 base model. You have to use both of these if you're using a 2.1. But since we're using a SDXL one, and you just got to make sure you check this checkbox right here for SDXL and leave these two alone. Go ahead and hit Save As. And I'm going to name this with a 1024 at the end in the same folder where I got the 768 one. I'm only going over the most important stuff about SDXL training in this video. But in this section, I'm going to be talking about how to prepare the folders for SDXL training. While filming the previous video, I figured out I was duplicating the regularization images every time I did this step. And you don't want to do that for 5,000 images that are 1024 by 1024. And that's in LoRa Tools Deprecated. Or depreciated. I prefer depreciated. How is it actually said? Tell me in the comments. See if you can tell me how to sound it out. I take my Burmy 1024 by 1024 folder. You all know how to make that. Obviously, what I mean is that you use Burmy to crop your images to 1024 by 1024 and put that into training images. And I'm gonna do Rebecca Ferguson with an underscore and then a 0. Previous video called Corrections LoRa video explains why I started putting a number towards the end. You can optionally just keep it like this, and your prompt will automatically blend your LoRa with the face for that same celebrity that the model's already trained on. Class prompt is going to be woman in this case. I'm going to go back to my data source images folder and go to view and then details and then sort it by type. So I can just click the first one and then scroll down and click the last one, and I'll know how many pictures it is. It's 44. And I want that to be more than 1,500, because that's the average good amount of training is 1,500 steps. So what I like to do is hit Windows button R, type calc, and hit enter. 1,500 divided by 44 is 34. So what's 36 times 44? 1,584. I like 1,600, maybe 1,700. So 40 times 44. That's maybe a bit much. 38 times 44. Let's put 38. 38. Regularization data, I'm going to leave that alone because I don't want it to duplicate all those gigs and gigs of 5,000 images we made. Destination training directory, I'm going to create a new folder with Control-Shift-N and type LORA-1024-SDXL. Press enter twice so I'm in there. Alt-D to get up here in the address bar. Control-C to copy the path. Paste it over here, hit the button that says prepare training data, and it makes all these magical folders for me. I'm gonna hit copy info to folders tab, and now we're gonna go back to training tab up here, so it's LoRa and then training, and then I'm gonna double check that all these folders are legit. Yeah, that's the one.
Give it a lick, man. Give it a lick just to make sure it's legit.
That's right, that's right. Now I gotta fix the output name to match the instance prompt we made earlier. I'll just do this. Placed underscore right there, put a 0 here. Okay. A little training comment, which I can see in Stable Diffusion later on. Regularization folder, what's its I'm going in here to get the path at that. I want to be in this folder where the one woman is, but not in this one where the pictures are, but in here. Copy paste this path into regularization. And now I'm gonna grab this, and now I'm gonna put underscore SDXL, or you can put 1024 dash whatever, you know, to remind you what it is. I'm gonna grab this and copy it and hit save as. I'm gonna go back to my celebrities, find Rebecca Ferguson, go in her LoRa 1024 SDXL folder, and then paste the name right here of that. Watch. And it saves it. And if it hits save as again, you'll see it with the .json extension on the end. All right. Now we're going to move on to the actual training parameters and how they're different from just training a regular LoRa. So click on your parameters tab. And in this case, batch size takes up different amounts of memory. I'll bring over my notes from when I was doing testing. On a 3090, batch size 1 took 18.5 gigabytes of VRAM, and ETA to complete training a LoRa was about an hour and 45 minutes. And then batch size 2, batch size 4, batch size 8. I was able to actually do batch size 8 because the RTX 3090 has a little bit more than 24 gigabytes of VRAM, so it was fine. But when I tried 16, it was through the out of memory error. So on the 3080 Ti, I was only able to do up to 2 on the batch size. But this was with network dimension and network alpha at 128 each. I also did some testing on the RTX 3070, which only has 8 gigs of VRAM. And this is what the console looked like after running overnight and all day while I was at work. Yep, that's right. 10 hours elapsed with 243 hours remaining. So since that's the machine I'm remoted into, I'm going to change that to a 2. So I said that too fast. I'm choosing batch size 2 on the computer with the RTX 3080 Ti. That's with the 12 gigabytes of VRAM. And past me forgot to say this. For SDXL training, you want to check the box that says cache latence to disk. This puts your latence on the hard drive or your SSD instead of into the VRAM. So that gives you a little bit more room there. In this case, you might try speeding up the learning rate by putting a 4 right there instead of a 1. So again, that's 0.0004. That's up to you. You can try it both ways. 0.4 is what I saw in another video on YouTube. We're going to change the max resolution to 1024, 1024. You get down here to this box's optimizer extra arguments. And I'm going to put this GitHub README in case you want to read it and try different things. That's up to you, but I'm going to give you the settings that worked for me. So the section that I've linked goes straight to the About SDXL training, and I was reading through here, and it's a lot to read. There's tips for SDXL training, fine-tuning with 24 gigabytes of memory, and I'm not going to dig it up right now, but somewhere in here it said it was possible to do training on 12 gigabytes of VRAM. Right here, he says training can be done with 8 gigabytes of GPU memory. 10 is recommended. This is where I figured out to use network dimension and network rank of 8 if you have 8 gigabytes of VRAM. So this means that higher dimensions in the vectors, or however it's called, in the LoRa training uses more VRAM to train it. So this is the ETA to train an SDXL LoRa that I got with the network dimension and network rank at 8. So if you have an 8 gigabyte VRAM GPU, these are your options. Option number 1, train with network dimension and network alpha at 8 and hope for the best, because a lot of people use 128 and it provides a whole lot better results. Option tuned, maybe training with more repeats or a few epochs or something will give you better results. Option 3rd, train in embeddings. I think they're going to give you better results. I did videos about how to do this. Option the 4th, stick to SD 1.5 training until you get a GPU with at least 12 gigabytes of VRAM. Like I said, I recommend the RTX 3060 12 gigabyte model. I'm actually going to be doing a video about VRAMs and GPUs and why I recommend that card, because long story short, it's cheaper but has enough VRAM. So make sure you're subscribed, because that's going to be an interesting video about hardware. Below the learning rate and above the max resolution, you'll find a box that says Optimizer Extra Arguments. This is where you put stuff you find in the GitHub README. Put these in and it will help prevent memory errors. You want cache text encoder outputs, network train UNet only, and bucket resolution steps of 32. First one, cache text encoder outputs. This caches the outputs of the text encoders so that it doesn't take up room in the VRAM. Network train UNet only. I'm not 100% clear on this one, but SDXL has a much bigger UNet, and you will have unexpected results if you don't put this in. Bucket resolution steps of 32. This uses the smallest possible setting for the resolution steps that still works with SDXL without messing it up, and uses as little memory as possible. I'll have all three together posted below in the descriptor what's its things for you to copy paste. And then you want to change your max resolution to 1024, 1024. And then down under SDXL specific parameters, you want both of these to be checked. And he talks about these in this article. So the cache encoder outputs checkbox, I don't know why they also have this checkbox when that GitHub README thing was talking about putting it in the other box. But I put it in and it seemed to work. No half VE. Like it says, VE for SDXL sometimes produces nans. So what a nan is, and I learned about this when I was doing cryptocurrency stuff. It's when you have a floating point number and the math doesn't work right. It doesn't know how to solve the algebra equation and comes up with an empty number. But that's just the gist of it. So check that box to prevent those kind of errors. I'm going to hit save before I move on. And the advanced section isn't at the bottom anymore, which I think is smart. Thank you, developers. It's much better right here as its own tab. Gradient cumulation steps 3 is what I liked from the previous video. There's another additional parameters thing, and I don't put anything in there. Gradient checkpointing check, memory coefficient attention, and cross attention or X-former. So these 3 things are memory things that we addressed in the previous video. But that's pretty much it. I may sound like I did a lot of talking. I just like explaining stuff. I'm gonna hit save. And by the way, just a little geekiness. This part right here, you can put anything in there, and that becomes part of the training command. So if I hit start training right now, it becomes part of this. Again, all this other stuff is the same settings that I showed you guys how to set in the previous video. So this, this image that you may or may not have seen go past your screen a few times today has got a couple LoRa's that I trained for SDXL in it, combined with Rebecca Ferguson, just the face that the model knows without using a LoRa, and Gal Gadot and Amber Midthunder. It's like a little bit of weighting on each. So here's some more. Here's the Gal Gadot LoRa that I trained. It's, you know, that one doesn't look like her as much as the other one. Here's Amber Midthunder. Some pictures of her. Those are from LoRa I trained. And then Billie Eilish. I do not know why this model wanted to put colorful things in the background, like all these shoes. Or she's at like a spice store or something. Like, what's up with that? There's the Amber Midthunder LoRa in an anime SDXL model I found. But guys, make sure that you're subscribed. I'm going to be doing an in-depth video coming up explaining why you need an NVIDIA GPU with 12 gigabytes of VRAM and how to find a cheap one. And my channel delves more into hardware than any of the other ones that I've seen, at least. So you definitely want to stick around so you can learn more about how to build a machine for this kind of stuff. And if you haven't seen it yet, you want to see the tips and tricks video for stable diffusions. It'll help you save time and get better generations. That's right over here. And this video is whatever YouTube thinks is best, and you can subscribe to the channel by clicking right here. All right, bye.